Hello YouTube, I hope all of you are enjoying your summer vacations and sorry but we have to learn science and in a fun way too. So welcome to another video from Science for Fun. Today we are going to learn about the relationship between pressure and volume of a given gas along with its mass and molecular weight. Now I have written a substance, just forget it, just consider it as a gas or a fluid. More specifically speaking, it can be a liquid also. So without wasting any further time, let's move in, and I'm going to tell you why we are going to need that thing, that relationship actually. And if you are an undergrad student, you must already know why we need that, but if you are in high school or you need to know, then let's proceed towards the video. So let's start by understanding n equal to m by m, the first equation. It shows that the number of moles of the given gas or fluid is equal to the mass divided by its molecular weight. Now why is that? Well, molecular weight is nothing but the weight of 1 mole of that particular element. So if I'm talking about oxygen, let's say, we all know that oxygen has a molecular weight of 16 approximately speaking. So if I'm talking about that we are taking 32 grams of oxygen, it means that we have taken 2 moles of oxygen. So 1 mole is equal to the molecular weight of that particular element. Now remember that this derivation is only possible considering the ideal gas situation. It is easier. It is not that we cannot derive it in the real situation, but considering the van der Waals constants involved there, it becomes a little bit tough. Moving on to the very next equation, that is PV equal to nRT. Every child from class 6 or 7 knows about this one. That PV equal to nRT shows the relationship in an ideal gas condition. Now putting the values of m over m in this place of n, we get the following equation: PV equal to m by m RT. Now what I'm going to do is consider that there are, let's say, two gases, G1 and G2. Now what I want to do, you folks, is that take P1 V1 for G1 at temperature T1, that is the gas is at a temperature T1 having a pressure of P1 and a volume of V1, and for G2 just take P2 V2 and T2, and then all of you make a ratio of G1 by G2. You can pause the video right here, write that down on a piece of paper, and then check your answer. So if you guys have done it, then this should be how the equation will look like. Now I haven't mentioned about M1 and capital M1 because I want to know how much you have learned since we have started the beginning in the video. I have specifically said that the mass is denoted by the small m and the molecular weight is denoted by capital M. No two different gases can have the same molecular weights. So M1 and M2 must have to be the two values. At two different values, make it remember that M1 is not equal to M2 in any cases. However, small m1 and small m2 can be equal. We can take 2 grams of nitrogen along with 2 grams of oxygen, but the molecular weight of oxygen and nitrogen will never be same. Now the R from here, which represents the universal gas constant, gets eliminated while taking the ratio. Now all we have to do is arrange this ratio. So let's do that. If we do that, we comes to this equation: P1 V1 by P2 V2 is equal to M1 T1 by M2 T2 and M2 by M1. Now what we are going to do is take some assumption here. If we assume that V1 and V2 is equal and T1 and T2 are equal, now how is that possible? Well, we say that we keep both the gases at similar temperature, at same temperature, and both at same volume containers. Then V1 equal to V2 and T1 equals T2. Then what happened? Well, it cancel out. Then we can say that if V1 equals V2 and T1 equal T2, we can cancel them, and then the final equation comes in hand, that is P1 by P2 is equal to M2 M1 by M1 M2. Now if you look closely to this equation, you can deduct some very important characteristic features of a gas. The first features that you can look here is that if we are taking two gases and if we want to know which one will have a higher pressure, then it will be very clear that for P1, the gas, suppose we are talking about P1 and P2 and we know that P1 is high, then we will automatically know for sure that the molecular weight of that P1 must be in its denominator, that is, pressure is inversely proportional to its molecular weight. So the higher molecular weight a gas possesses, the lower pressure it will have, and vice versa. But at the same time, if you observe, the second as a notification that we get from this equation is from its mass. The higher the pressure is, the more mass it must have. So if I am talking about, if you want to take nitrogen and oxygen, we all know that oxygen has a higher molecular mass than nitrogen, which means that X gram of oxygen will have more pressure at same volume and temperature than same X gram of nitrogen. If we want to increase any one of their pressure, what we have to do is we have to pour more substance. That's pretty common also. You can explain, if you want to expand a balloon filled with helium gas, you have to pump in more helium gas. That's it. So if we increase the mass, the pressure will increase. But if the molecular mass of a substance is higher, then its pressure will be lower, and vice versa. I hope this clears a new concept of chemistry, and more specifically about gas and liquid. Together we can say of fluid dynamics. So that's it, folks. If you have any query, please put those in the comments down below. If you want to give some suggestion, I am always all ear to hear those things, no pun intended. And please like the video, share it, and do subscribe. It really helps the channel. Thank you. See you again. Till next time. Goodbye.